Well, hello students. I wanted to take just a short time and record a video on how to use this molarity molar concentration simulation on the PhET website to go along with the activity that I've got planned for you guys. You can see on your left right there I've got the simulation itself, which you can either find linked to at the bottom of the page, just PhET Colorado EDU. Just do a search for PhET molarity and you should be able to find this. And then the activity itself I'll have posted over at Google Classroom. I'll also have a link for anyone who's not one of my students to where this is found at the Teachers Pay Teachers website. But the activity encourages you, first of all, to start playing around with the sim. The first thing we're going to come over is we're going to come over here, we're going to check this little box that says solution values. And what that's going to show us is it's going to show us the molar concentration over here on the right on the scale. This lets us, these two sliders let us adjust the amount of solute with this, and it also lets us adjust the volume of solution in liters. And so you can kind of see some definite changes that happen as I raise or lower one or the other. Not only does that affect the molar concentration, but if you take a look at the beaker itself, it also shows you a change in the color there, the color intensity. So in the activity itself, part one, we are looking at determining saturation concentration. So we're looking to see how concentrated we can get each of these different substances before they get completely saturated. So we're going to go through, we're going to start with cobalt chloride here. I'm going to come to the drop-down menu, pick cobalt chloride out. Now what I'm trying to do is I'm trying to get to the saturation point. So I'm going to do that by adding as much solute as I can and then decreasing the amount of solution that I have. And if you take a look right in here, it pops up with this little message that says saturated. And you can see there's even little particles of solute that are building up at the bottom there. What I want to do is I want to come over here to the scale. I want to see what my concentration is. It says it's 4.350 molar. Come to right here beside cobalt chloride. And here beside cobalt chloride, which is the substance I just tested, I'm going to write the saturation concentration there, which would be, again, this 4.350. I'm going to do the same thing with each of my other solutes and so potassium permanganate is the next one, and you can see I'm already starting out with it saturated. So in this case, I'm going to increase my solution volume, and if you have to, you might even decrease your solute volume. You see right there, I'm starting to get a change in my concentration, so I bring it up until it just says it's saturated right there. And again, I'm going to record that molar concentration where it hits saturation point right there beside that substance. And you do the same thing for the rest of your substances there in part one. Now then in part two, you're going to be doing some molarity calculations and you're going to be using drink mix. So I'm going to come back over to my sim. I'm going to choose drink mix, which, you know, we call it drink mix because we can't say Kool-Aid apparently because, you know, that's copyright. I hope they're not watching this. And for the rest of this table, they want you to find the molarity. Now you can do this a couple different ways. You could, of course, use your molarity equals moles of solute divided by liters of solution formula, which you learned. But for right now, what it wants us to do is it wants us to use the simulation instead. So instead of mathing this out, I'm going to set my moles of my compound to 0.53. So I'm going to come over here and I'm going to get it as close as I can get it. You might not be able to get it right at 0.53 If you can't, then just do your best. I'm having a really hard time fiddling this just right. I think 0.531 might be my best bet, and that's going to be close enough to get a good answer. And then liters of solution, it wants 0.79, so I'm going to change my liters of solution to 0.79, or as close as I can get to 0.79. I'm not sure if using a touch screen would make this any easier. Trying it right now, and the answer is not really. So get it as close as you can get it. Understand that since I'm wanting you to use the sim for this, if you get results that are too perfect, I'm going to know you just, well, cheated with the math instead of actually doing the simulation. So when I've got that set as close as I can get it, I come over here and I take a look at the concentration. In this case, it's 0.670, and that would go here where it says molarity of solution. And you're going to do the same for these other three on the left side. On the right side here, it may be asking for something different. So in this case, it wants me to have a molarity at 0.59 and liters of solution at 0.78. So I'm going to set my liters of solution at 0.78. Oh, I had it. So close. That's fine. And then I want my molarity to be 0.59, so I'm going to watch the scale here with my molar concentration while I play with my amount of solute until it comes down to 0.59, or as close as I can get it. That's pretty close. And so to fill in that moles of compound, I would use what it says here, which is 0.461. Yours might be a little bit different, and that's really fine. Now when you get down to the post-lab questions here, some of these you're going to be playing with the simulation to help you explain your answers. Some of these, the simulation isn't going to work for you, and you are going to have to jump in to using the math. So just don't look at those and throw up your hands and quit, and for sure don't skip those because they are worth a decent chunk of the grade on this. But just do the best you can. Puzzle it out, play with the simulation on some questions, and that may be enough to get you whatever information you actually need. And just do the best you can. Don't give up.